Ramanujan for G is now available on the Google Play Store. Try it out for free.
Yeah, sorry, I forgot to share the screen. So again, good morning all. So first we started with the additional theorem. Okay, so like if A and B are any events in S, then P of A union B is equals to P of A plus P of B minus P of A intersection of B. Correct? So here set S is given for the universal set, and that we are having two different sets A and B. Correct? So next, what we have done, we are written for the three common terms P of A union B union C. That is P of A plus P of B plus P of C minus of P A intersection B minus B of B intersection C minus of P C intersection A plus P of A intersection B intersection C. Correct? So first you need to copy this, then we'll proceed to the next part. Okay, next we have solved for the general form of the addition theorem, that is n events are given from a1 to the an. Okay, so all these are in the form. So summation I equals to 1 to the n p of ai minus of summation I less than j. Okay, then we'll proceed to the I less than j less than k. So all three intersection we're gonna take and we'll solve. So final answer will be p of a1 plus p of a2 plus p of a3 up to the p of an. Correct? And here we're written as p of a is equals to 1 minus p of a, which is a union a dash, which become S universal set, and a intersection a dash, which becomes phi. Okay. Okay, so now here we're gonna take one question. Bag contains 6 white, 5 black, and 4 red balls. So you need to find the probability. Find the probability of getting. Okay, just a minute. Let me check the question first. Yeah, you need to find the probability of getting. There's a little bit confusions of data. Okay, no issue. We will solve with different data. So we need to find the probability of getting either a white or a black ball in a single draw. Okay, so first we're gonna write let A is event that we get a white ball. Next, B is equals to event that we get black ball. So next events are, we can say, mutually exclusive. That is P of A is 6C1 by 15C1, and next is P of B is 5C1 by 15C1. So finally we can write probability of A plus B, which is P of A plus P of B, that is 6 by 15 plus 5 by 15. So the answer is 11 by 15. So this is our answer. First you need to copy this example, then we'll take one more. Okay, so next question. One digit is selected from 20 positive integers. Okay, so what is the probability that it is divisible by 3 or 4? So solving, we can write let event that selected number is divisible by 3, and V is equals to event that selected number is divisible by 4. So events are not mutually exclusive. So P of A is 6 by 20, P of B is 5 by 20, and P of AB is 1 by 20. So P of A plus B is P of A plus P of B, that is P of AB. So now we can say 6 by 20 plus 5 by 20 minus 1 by 20 is equals to 10 by 20, that is half. Okay, yeah, so need to copy this question and let me check the data again. So like 6 by 20 plus 5 by 20 minus 1 by 20. Okay, correct. Yeah. So addition theorem we are done. Okay. Next, we'll start with the multiplication theorem. Okay. So here, first is when events are independent. That means if A1, A2, and up to AN are independent events, then P A1, A2, AN to PA1, PA2, and P of AN. Correct. So if A and B are two independent terms, okay, then happening of B will have no effect on A. Okay, that means P A by B is P of A and P B by A is P of B. So we can write P of A intersection B, that is PA into PB into PB. Okay, or we can write P of AB is PA into, this is PA into PB. Okay, so this is for the events are independent, correct? So now next we will proceed for the events when events are not independent. Then what we can do, let me put the heading when events are not independent. So in this case, the probability of simultaneous happening of two events A and B is equals to the probability of A multiplied by conditional probability of B with respect to A. Okay, so or we can say probability of B multiplied by the conditional probability of A with respect to B. That is, we can write P of A intersection B is equals to P of A into P of P by A, or P of P multiplied by P of A by B. So again we can write P of AB is equals to PA P of B by A, or we can write P of B into P of A by B. Okay, so with this we can solve the problem. Now we'll see some example based on this. Okay. Okay, so let us look at example. Like a bag contains 4 red and 4 blue balls. So 4 balls are drawn one by one from the bag. 4 balls are drawn one by one from the bag. Okay, then find probability that drawn balls are in alternate color. Okay, so solving. So even we can write event sorry, first drawn ball is red. This is the even first event, and second is blue, and so on. Next, E2 event, first drawn ball is blue, second one is red, and so on. Correct? So we can write P of E1 is 4 by 8 into 4 by 7 into 3 by 6 into 3 by 5, and again P of E2 is 4 by 8 into 4 by 7 into 3 by 6 into 3 by 5. So we need to add P of E1 plus P of E2. So that becomes 2 into 4 by 8, 4 by 7, 3 by 6 into 3 by 5. So solving will get this 9. So between 4, 8, 1, it will be So it will be 6 by 35. 6 by 35. Okay. So this is the answer. Copied. Next, let us look at one more problem. Okay. That is, three coins are tossed together. Okay. Now, what is the probability? What is the probability that first shows head and second shows tail, and again third shows head? Okay, solving. Let A, B, and C denote three given components of events which are mutually independent, that is P of A, B, C, that is P, A, P, B, P, C. We can write half, again half, and half is equals to 1 by 8. Correct. So probability of getting first source head, second source tail, and third source head is 1 by 8. Okay. So with this, we have completed the additional theorem and the multiplication theorem. Okay. So in the next class, we'll start with the conditional probability. Okay, conditional probability. First, you can copy this. Okay, so thank you guys.